Good morning, Latifa.
Morning.
We're waiting for a few other people.
Are we using the virtual stuff today? Because mine is still downloading. Oh.
What about the Ubuntu one?
Yes.
No. We'll start that either next week or the upper week. I just wanted everybody to
Okay.
be ready.
Okay.
What is downloading? The software?
Yes. It's here a server that is downloading because the server that they said I should download. And the UTM for MacBook.
No, I think it should be down. Okay, well, yeah. You should be the server.
Then the UTM for MacBook.
Yeah. You followed the YouTube
Yes,
video?
yes, I did.
Okay,
Yeah.
okay. That's fine. Were you able to log into the website to download the materials?
I really like this dress again. It's back. But I have this costume. What's my perfume?
We'll start in another 5 minutes.
That is funny. No, I like there's one that someone bought for me from London. No, not red. Let me show you. But that one is finished because I was using it.
So the assignment for last week, were you able to go through it? Hello? Hello? Hello, good afternoon.
Good afternoon.
Yeah, good afternoon, Akpabi. AKP, sorry. Were you able to go through the assignment for last week?
Myself?
Yeah.
No, I was not.
Okay. I just want to do a quick review
Okay.
of what it was. So I think let me share that slide first before we move into this week's. Okay, so we're gonna go through the last week's assignment. I'll just go through it quickly. So I said pick any application on your phone and break it down using the OSI layer. So the first thing you need to look for is what is OSI layer and how does it work? Remember we said that there are two different protocols when it comes to connection solutions. One is the telecoms mobile solution, which goes through the radio wave, and the other one is the internet solution, which goes through the LAN or wired connection. So there are two different kind of industry standard of connection. So which means you can either connect to the internet using your phone, you can open your phone and browse or call, or you can use your laptop to connect to like a LAN cable or to a Wi-Fi through the internet layer. So when we say OSI layer, the layer we're looking at is your connection going through the internet via like wireless connection or a LAN cable. So when we now say the SS7 protocol, that's the one that goes through your phone, the telecoms connection. So you have to be able to break that down to understand that one goes through radio wave, which is a mobile telephone connection, and one goes through your typical internet, which is through your maybe your laptop connects to a LAN cable or internet Wi-Fi. If you're using an hotspot on your phone to connect your laptop, that is no more internet through the typical solution. It's internet through mobile because your phone is using a radio wave. So you have to be able to decipher both of them first to understand how this works. Because it can be a bit confusing if you think that your phone connects using the typical internet. It connects using radio waves because it connects to the mast, like you said, and the mast is the BTS, that then transfers to the MSC, which means it's going to use the SS7 protocol, not the OSI layer. So someone from the team sent their assignment to me, and I was very impressed about it. So basically, we're going to use Snapchat. But since we said it's going to be through your laptop, so we're going to assume that you launch your Snapchat on your laptop. And that means your Snapchat itself is your application layer, which is the Snapchat code. That means when you install Snapchat on your laptop, the code that runs behind your laptop is the application layer of the Snapchat. That is unique or proprietary to Snapchat itself. Then we go to the presentation layer. That is the layer that connects your Snapchat applications to your OS, if you're running a Mac or a Windows system. So the interface between your Snap running on the OS is the presentation. How both of them communicate to share the information that the layer below it understands. So the OS layer breaks down Snapchat into codes that are able to be encapsulated and decapsulated for transmitting network, so into like industry standard data. Then we have session. So session will be when you launch your Snapchat and you're trying to take a video and post it. That moment when you launch it and take a video, it creates a session between your application and the server itself, the server side, which is the Snapchat server wherever it is in the world. Because I hope you know that when you post a video on Snapchat, it's not staying on your phone. It's staying on a server somewhere, maybe in US or in Canada, wherever the Snapchat server is. That is where your video is going to be held. And that is where you can go back and view your videos for 24 hours. So it creates a unique session for that moment when you try to post a video. Then we go to the data link layer. So that creates the layer where, we go to the network layer, So that creates a secure connection between your laptop and the Snapchat server. So it creates a sort of like a three-way handshake, so that data can pass between your laptop and that server. If the server is in, let's say, US, it creates a unique pipe. It's called a trunk or a virtual pipe between your laptop and the server, where data can transmit in real time without being mixed up with other data passing over the network. So that's what a TCP/IP network layer does. And the data link now encapsulates all of your data, all of the videos you put in the snap of. It encapsulates into a packet or into a data packet, and then pass it. It's like a trailer. So it puts all those information into the back of the trailer, and it drives them through the network to the server. And then we have the physical layer, which is the bits and bytes, the ones and zeros that passes through your the physical network. So zeros and ones that goes through. So that's basically how you break it down for that scenario. Then I said, take a picture of a mast. I think we've all seen a mast from the last, so that is not here. I just want you to have a feel of it. The mast is the one on the far left corner left corner on the screen here. So that's the mast. Then, so on the mast, okay, I said, okay, label it. The one there is the microwave drum, and the rectangular one is the radio transmitter and receiver. And the transmitter and receiver is meant to connect to your phone, passing data through the uplink and downlink, while the microwave drum is meant to push your data that is received by the transmitter to the BSC, and then for onward and travel to the MSC and whatever next node, subsequent node there is. And I said, if you're traveling from Lagos to Ibadan and start a phone call at the Lagos toll gate, what telecoms equipment is responsible for making sure you have network connectivity for the call as you travel without losing signal connectivity during the call, and what is this process called? So basically, if you start a call at, let's say Lagos, that means your phone is connected to the mast closest to you. There's probably like a mast around the toll gate area. Now, as you drive from Lagos, let's say you're reaching about like 10 to 15 minutes into the journey, the mast that you connect to will start receiving lower signal from your phone, which means it will affect the call quality if nothing is done. So what happens is your phone calculates and looks for the nearest closest mast to where it is. Now, this process of calculation and looking for the nearest closest mast, and then transferring your call to the next mast is called handover in telecommunications. It's a very core word you need to know, handover. What is responsible for this handover is the BSC. Remember we said the BSC connects all of the, the BSC connects all of the BTS or the mast within a geographical location. So the BSC, which is the base station controller, connects all the base stations within a location and is able to like transfer your calls from A mast to B mast to C mast as you travel within that journey. So the BS is what does that, and the process is called the handover. So for question 4, we said what telecoms equipment is responsible for tracking your specific geographical location in real time based on your phone location. So we mentioned that in the last class. We said the VLR, Visitors Location Register, is responsible for knowing where you are at every given point in time. So if you're moving from, let's say if you're going to work every day from Lekki to Aja or Lekki to Yanapaja, the VLR, which is the Visitors Location Register, records your geographical location at every given point in time. For the purpose of being able to route any telecoms request to your phone in real time. So the VLR has a record of where your phone is at every given point in time. So that is the answer to all of that. So we can start this class. Today's lecture. I'm going to try to rush it as quickly as possible, because some of us need to get something. So please, guys, try to sort out your Ubuntu installation for your Windows or Mac. We are going to start the practical class either end of next week or upper week, so that nobody's left behind. I just want to I want to make sure we all understand the concept before we start running on the practical, because if you start practical first, you'll be lost. We have to build you up to understand the whole before we go into the practical class. So basically, this week is going to be intelligent network, OSS, BSS, VAS, call, SMS, data VAS, basic call, recharge and data flow, redundancy, high availability, and business continuity management. So that is what we're going to go through in this class. Some of these things we spoke about in the last 2 previous classes. So I think you probably have an idea of what they are. So when we say intelligent network, this layer writes, we said there are 3 core parts in telecommunications. The access network or the radio network, which is your base station, your BSC, like everything that is outside of the network, that you see in the radio, in the air. and the core network, which is your MSC, your HLR, and the rest, which is within the data center. And then we have the IS layer, which is the OSS and BSS. Now that is layer where the intelligent network writes. So basically, here is the definition of it. And the two important information you need to see here is that it provides value-added services powered by network nodes on the service layer. So basically, it rides on the core network layer to provide intelligence. Intelligence means that it's able to provide value, provide profit for the telecommunications operators. So that layer is what you see here. So you can read through the definition and just understand what that means, but that is basically what the intelligent layer speaks to. So if you look at it here, you can see, let me get my pen. You can see we have the access layer here for the radio network. We have the core network here. So beyond this place now is now where we have the intelligent network. So what that means is that for you to make a call, for the purpose of making a call, you actually don't need this layer, the IN network. And sometimes when you say you have free calls on your phone, maybe MTN sends you a message saying they're having an upgrade and whatever, and you notice maybe at that night you're trying to make a call and you're not being charged, it's because they disconnected this layer because they're doing an upgrade or they're doing a maintenance. So basically, when you make a call, it comes this way to the MSC and it goes to your destination number that you want to call, which means you're not being charged. Because for charging to happen, for them to charge your account or to take your credits, the call has to be routed to the IN layer for processing, to check your account balance and other things, and then send the charging request down. So when they disconnect this layer from you, you're able to make a call seamlessly without being charged. Which is why the IN network is very important, or the IN layer is very important, because that is where all the intelligence happens. That is where you get charged. That is where all your profile information for your credit, for your account balance, the products you registered for, any other thing you think of, this is the layer where those information exist. So so if you look at the second diagram on the right here, you can see for a typical call, your call comes into the exchange. Exchange here is talking about your MSC. Remember we said MSC is your mobile switching center. So when you hear exchange and switch, they're the same thing. So your call comes to your MSC and the SSP. And then so they're looking at the scenario where you're being charged or where it goes to the IN network. Your IN network is your SCP, service control point. It controls the service. So your service control point. So you can see the call comes here and then it looks at the database, checks your profile, sees that you have let's say 100 Naira. And then you advise the exchange that, okay, this subscriber has 100 Naira. 100 Naira amounts to 3 minutes of call. So allow him to only make 3 minutes of call. So it sends that response back to the SSP. SSP holds that information and tracks your call. As you're making the call, it's tracking your minutes, 3 minutes. Once it gets to 2 minutes and let's say 49 seconds, it plays an auto message saying, dear customer, your credit is low for this call, blah, 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 blah. So that is what makes you hear that voice call when the IN advises the exchange about your account balance and all of that. And then your call then gets routed to the destination number with that profile that he has, that, okay, he has 3 minutes, so I can only allow him to make 3 minutes call based on the account, the credit he has. So that is typically what happens on that layer. So are we all following? Do I need to clarify anything before I go to the next slide?
I'm following.
Okay, thank you. Because you can always stop me asking a question. Like I said, anything that is not clear, just let me know. I'll be glad to